All right, explaining compound interest. Here's what compound interest does. You put money in a bank. The bank then gives you a certain percent back at the end of the year, or maybe every month, or depending when they decide to compound your money. I know, like, usually a typical savings account, how often do they compound? Do you know?
I have no clue.
It's every month. Yeah, I do the bills. So it's every month your savings account.
I learned something.
Every month your savings account earns you a little bit. Now, our savings account earns us maybe like $1.20 every month. Woohoo! Okay, but still, at least we're making some money off of it. That's like kind of like the bank's pathetic way of saying thank you for letting us use your money. Okay, but here's what happens with compound interest. So I put in X amount into the bank, right? And the bank gave me a little bit back. Now next year, my new value that the bank's going to give me isn't just on the value I put into the bank. It's on the value I put into the bank and what the bank gave me that previous year. So it's going to be a little bit
more.
That's right. So every year it gets a little bit more, a little bit more, a little bit more, a little bit more. And that's the idea of compound interest, because the bank's giving you money on top of the money they've already given you.
And who doesn't like more money?
That's right. Even if it is $1.25 instead of $1.20, what the hey? Give it to me, I'll take it. All right, are you ready? Finance. Suppose when your friend was born, your friend's parents deposited $2,000 in an account that gives 4.5% interest compounded quarterly. There's a lot of information about the fact that they do it quarterly, okay? We'll talk about this equation in a second. What will the account be after 18 years? And they should put in there pending nobody puts anything extra in, and pending nobody takes anything out. So this $2,000 is sitting there, okay? $2,000 sitting there for how many years?
18.
And just so you know, a bank will never give you 4.5 interest, okay? A bank is going to give you like 0.1 interest, okay? But the idea is this must be the best bank in the entire world, or maybe it just makes your problem more understandable, and that's why they picked it. All right, we're going to use our typical formula, guys. A stands for, now, you can use this up here, but the idea is kind of the same. A, you know what, in fact, maybe I should explain that. A stood for the what at the beginning? Do you remember?
Initial amount.
A stood for the initial amount. Well, guess what? So in this problem, P stands for the initial amount. They just use a P because it stands for principal. But it's still the initial amount. So it's like the A. Do you see this huge parenthesis right there?
I see it.
That huge parenthesis is essentially the letter B. It's 1 plus your percent. That's pretty easy, right? 1 plus your percent. You're not going to do minus your percent because your bank's not, hopefully, taking money away from you. N is how many times it happens in a year, and T is how many years you're looking at, okay? So let's go ahead and try to use that formula. So we get A, which is the balance, because that's what it says it is, equals how much money was put into the bank?
$2,000.
That's right. And then we get this parenthesis here. Again, this is really just the same thing as the letter B, but we'll write it out. It's 1 plus. It's always 1 plus or 1 minus. When things are growing, it's 1 plus. What's the percent annually? What does it say? Why? I'm sorry. What is the percent? Let's just do that. What's the percent?
4.5%.
Okay, 4.5% as a decimal is actually, though,
0.045.
All right, as a percent, as a decimal, 0.5 is 0.045, and that's where I'm going to lose a lot of you guys. You guys are going to get these huge amounts, and it's because you don't convert the way you should. Now, we got to put this over how many times it happens in a year. So if something happens quarterly, how many times does it happen?
4.
That happens 4 times a year, okay? That's where we're getting that 4. Quarterly means 4 times a year. Now, our formula says you don't just take it to how many years it is, you take it to how many times it happens a year.
4.
And you multiply by how many years we're leaving it in the bank.
18.
18. So do you guys see this problem? This is what we're going to do. Now, here, tell you what we're going to do. It comes from my lip, Lucy. Okay, leave everything else alone. But I do think it's a good idea if you do 4 times 18. What is 4 times 18?
72.
72. He did that at the top of his head. That's right. Smart cookie, isn't he? All right, so here we go. We're just going to plug this in the way you see it. If you've got a smartphone, you may want to do this inside stuff first, but no rounding. You ready to get our answers? $2,000 sitting in the bank. It compounds quarterly. That's how much money this person's going to have at the end of 18 years. What do you think about that? Would you put your money in this bank?
I like that.
Why?
Because it's more.
It's not just more, is it, though? It actually it not only doubles, it's more than doubling your money, isn't it?
Yes.
So if you can be patient for 18 years and see that money more than double, I think it might be worth it. All right, we're going to do this again. Hey, look how often this problem is compounded. Suppose the account in problem 2 pays interest, but it's compounded how often?
Monthly.
And that's like a typical bank. A typical bank does compound things monthly. Now, a typical bank doesn't give 4.5%, but hey, whatever. You find that bank, will you please let me know? I'd like to take all my money there. Are you ready? A equals, what was the initial amount?
2,000.
Okay, the parentheses almost stay the same, but what's different about the parentheses this time?
12 instead of 4.
Why is it 12 instead of 4?
Because it's monthly instead of quarterly.
Good, and a month happens how many times in a year?
I think 12.
That's right, so we do 12 times how many years?
18.
18. Now 12 times 18 is a very, very, very large number. It is?
216.
Alright, so what we're going to do is we're going to do 2,000. Keep your parentheses the same. You might want to put your parentheses and get yourself a real answer if you have a smartphone, but hopefully you know how to work your parentheses on your smartphone by now. Are you ready? 2,000 times 1 plus 0.045 divided by 4. Why did I divide by 4? You didn't catch me.
Because you
He didn't catch
did
me.
quarterly instead of monthly.
I did quarterly instead of monthly, and you divide by 12. That's okay, I'll forgive you.
Oh, thank you.
You're welcome. Look at that, guys. You get a little what? A little more or a little less?
A tad bit more.
A tad bit more. I'll take it, right? I take more money anytime people are willing to hand it out, right? I hope you're rounding to the nearest penny, since money is in terms of penny, right, everybody?
Right.
Yay, okay, good. He answered for you. I like that, too. Now, why are you getting more money? Because it's compounded more often. All right, moving on. Ooh, decay. Decay is kind of cool. Okay, decay does this. It shrinks, okay? That's what decay does. In these type of problems, B is going to be made up of 1 minus the percent. Technically, the percent is negative, so that's what's going on when we deal with decaying problems. Decaying problems are just like growing problems, except you subtract instead of add.
How about that?
Is that too hard?
I don't think so,
Not
Mrs.
too-
Langella.
Oh my goodness, star student, E+ for you.
Thank you.
All right, look at the graph, how it's a little bit different. This time, can you see it as you read left to right, how it shrinks?
I see that.
That's right, that's what a decay does. Well, what happened left to right on a growth?
It went up.
It grew. Imagine
Wow.
that. But you want to see something cool? You see how A was the y-intercept on this problem?
Yeah.
Guess what? A is the y-intercept on this problem as
You've
well.
just blown my
I
mind.
know, and A is always the what?
Initial amount.
And B is the base, so it would be either 1 plus or 1. And
Minus.
since we're doing decay, it's going to be 1.
Minus.
Dun, da, da, da. So smart. Okay. Now let's take a look at problem 3. Physics. Oh, good. That's more me. The kilopascal is a unit of measure for the atmospheric pressure. Dun, dun, dun. The atmospheric pressure at sea level is about 101 kilopascals. For every 1,000 meter increase in altitude. Do you
That's pretty
understand
high.
that? 1,000 meter. So this is every time it goes up 1,000 meters, the pressure decreases about 11.5%. That's why whenever like people climb a mountain, you'll never see me climbing a mountain, but that's why the air pressure gets very low. Okay? It's very hard for them to breathe.
And if you go up enough, then you're just in outer space.
Yeah, but don't go up that far. I bet they're laughing at home right now. You should be laughing because we're hilarious.
Or just
okay.
rolling their eyes.
They probably are just rolling their eyes. They're probably just wanting me to move on so they can finish their notes.
Probably.
Do you want me to move on?
I haven't heard anything yet.
I haven't heard anything either. Okay. We still do y equals. I'm going to go back to the basic equation because we're not dealing with money. Y equals ABX. Okay? A times B to the x power. What's the initial amount at sea level?
101.
Kilopascals, right?
That's a fun word.
That kind of is. Now that is going to be times. Now we got to talk about what B is made up. This time B is going to be 1 minus, because what's happening?
It's decreasing.
It's decreasing. The atmospheric pressure is decreasing. Every 1,000 meters we go up. Now, what am I subtracting? I'm not going to subtract 11.5 because that would be crazy. I'm going to subtract
0.115.
That's right. You guys must be able to convert your percents into decimals. If you don't know how to do that, just divide by 100 and that will do it for you, okay? Do you know what that answer is?
No.
Yes, you do.
It is it 70?
No.
Is it 885?
Yes. 1 minus 0.115 is 0.885, and that is the value of the B, okay? And that is to the x power, but we got to be careful here because I'm not quite sure if they actually know what x means, because x isn't time in this problem. X has been time in every other problem that we've done, hasn't it?
Yes.
Yes. This time x is every 1,000 meters that you go up, okay? So 1,000 you would plug in what? After how many, like if you were to plug in 1,000 meters up, you'd actually only plug in 1. If you were to go up 2,000 meters, you'd plug in 2. If you were to go up 3,000 meters, you'd plug in
3.
Because x represents every 1,000 meter increase. Did I make that clear?
I think so.
Do you think they get it?
I'm clear.
Okay, if you are, then I'm going to hope
Okay.
they are, okay?
I hope
now,
so.
this says that in this problem, how far up do we go?
3,000 meters.
In this problem, we go up 3,000 meters. So since x is in terms of how many thousands we go up, what am I plugging in?
3.
3 for x. Well, let's see what the atmospheric pressure is up at 3,000 meters. $70.008, so we're just going to write squiggles 70, and we got to put our units on there, kilopascals, and I'm not sure how to abbreviate that, so I'm going to write the whole word. Okay, you can ask Mr. Ledbetter when you see him next semester, like you'll remember, right? Okay, do you have any questions?
No.
Do you think they do?
Maybe.
Do you
No,
think the
they don't make questions.
Do you think the hardest part is going to be for them to put 3 here and not 3,000?
That could be tricky.
I think it's going to be hard for them to remember to change it to a decimal too.
Well, that could be.
Just maybe a couple of them.
Maybe.
Should I pick them out?
Sure.
That would be mean. He's mean.
Don't do that.
I won't. Part 3. What is the atmospheric pressure at an altitude of 5,000 meters? Well, guess what? The initial amount, sea level never changes. So what's the initial amount?
101.
And the percent of change never changes. That sounded funny. So B is still what? All of B.
885.
0.885. That's right. That's not changing because it still holds true to all the information above. The only thing that's changing now is instead of going up 3,000 meters, we're going up
5,000 meters.
So instead of plugging 3, we're plugging in
5.
Look at that, because it's in terms of every how many meters?
1,000 meters.
That's right. And how many 1,000 meters fit in 5,000?
5.
There we go. Do we get that good enough for them?
I think so.
I hope so. They probably already have this typed in their calculator and just
Probably.
waiting to see if there's any bonus. There's no bonus today, guys. So if you're done, you can turn off the computer.
Aww.
Aw, bye. Okay, not yet. Let's get this finished. 54. Let's just round it to approximately how much?
If that rounds down to 13? No, 55.
55 what?
Kilopascals.
Yay! Kind of cool, right? Part B. That was part A. Part A. Part B. Why do you subtract the percent of decrease from 1? And this could also ask, why do you add the percent of increase from 1? So why do we use that number 1 for our letter B? Why do you think?
Because 1 is 100%.
Yeah. You guys know that 1 as a percent is 100, right?
I know that.
Do you know that?
I do
you
know
think
that.
they knew that?
Think
They
so.
should know that. They're honors. I should know that.
So then when you subtract, you should never get negative because you can't go below.
Yeah, you can't go below like a negative. So that's why, guys, when something increases, we add it to 1 because it's going from 100% to whatever we get. Whether it's adding 7%, it's going from 100 to 7 to 107%. If it's decreasing 7, it's going from 100% to 93%. So if you ever notice that we're always taking it or adding it away from 1, that's because 1 is our original amount, and our original amount always has 100% of what it originally had.
There you go.
So if it's increasing, boom, in it, add it in it. If it's decreasing, subtract it. This is your lesson check. If you have any questions, if you kind of struggle there, I would really suggest going over this, setting some up. If you have questions, come in tomorrow, please ask them. Don't go through not understanding what you're supposed to be doing.
Can I show my hands on the video?
Oh, yes,
See?
absolutely.
She has her hands in the video. There you go.
Mine are much prettier.
Yeah, that's true.
Is that all you want? Do you want to show your face?
No.
I took off my makeup, so I'm not going to show my face.
That's all right.
Okay. Want to say goodbye?
Goodbye.
Goodbye.